All right, right now we're looking at 1027, which means up to this point you've completed 10, 24, 25, and 26. In 1026, they showed you different ways that you could rewrite one of those equations in order to make it a little bit simpler. And then you got to C. And C looked like a little bit of a challenge. And then if you figured that out, and you figured out that you could have just multiplied everything by 3 to get rid of that divide by 3, they now throw a question at you that now has two fractions. We've got a divide by 6 and a divide by 8. And as you walk through 27, you should have done that already. If you didn't walk through 27, pause the video now, do that. But if you've already walked through 27, you found that multiplying by 6 got rid of our first fraction, x over 6, and the 6 canceled, but it didn't work with the 8. If you found multiplying by the 8 got rid of it, and then got rid of the second fraction, but not the first fraction. And they challenge you then to find a number that you could multiply by so that it would get rid of both 6 and 8. Essentially, what they're asking you to do is they're asking you to find what we would call the LCM, or least common multiple. The least common multiple, the LCM, for, in this case, 6 and 8. All right? And what is the least common multiple for 6 and 8? That means the first multiple that both 6 and 8 go into. And if I look at 6 and I start counting the multiples of 6, I've got 6, 12, 18, 24, 30, and so on. If I look at the multiples of 8, it starts with 8, then goes 16, 24, 32, and so on. And we see the first common multiple that we come to is 24. That's one number that both 6 and 8 go into. And if you figure that out, then they challenged you to multiply every single one of these terms by that least common multiple. Why did we multiply everything by 24? Because, well, the multiplication property of equality says that if we multiply one thing by 24, or more specifically one side of the equation by 24, we have to multiply the other side of the equation, and that refers to the entire side. I can't just do one term, I got to do that whole side. But when we do multiply by 24, I see that 6 goes into 24 4 times, 8 goes into 24 3 times. There's no fraction on the other side, so nothing cancels there. But this allows me now to simplify my equation down, giving me 4x minus 3 times 5, which 3 times 5 would be 15, equals, and on this side we've got 4 times 24, and 4 times 24 is 96. Now we've got one equation with no fractions, making it much easier for us to go ahead and solve this by adding 15 to both sides, and then dividing by 4. And in this case, we find that x is equal to 111 fourths if you leave it as an improper fraction. But if we take that, we could go down a little bit further. That is 27.75 if we do that division, take it down to a decimal. And that's a value of x that would make this equation true. And we got there by eliminating our fractions by multiplying by the least common multiple. This is a process that we're going to come to know as fraction busters. Tomorrow, we're actually going to get into this a lot more and see why we need to learn it and where it's useful as we get into some more complicated problems. But for right now, move on to 28, and let's take a look. In 28, it says that I'm going to give you an equation. So here's 2, all right? And it says you're going to take one of these equations and you're going to make it more complex for your partner. All right, so pick a partner. If you don't have a partner, get with one. All right, what I want you to do is pick one of these two equations, either one, doesn't matter, and then I want you to turn it into a fraction in some way. I'm going to show you how I would do it, but you can pick your own, all right? And you can't use mine, all right? So in this case here, I'm just going to take my first one right here. I'm going to take 4x minus 2 equals 6x, and I'm going to change all these by multiplying all these into like a giant fraction here and get some things going there. So you could simply say, I'm going to go 4x over 5 minus 2 over 5 equals 6x over 5. All right, now I've made it a little bit more complicated. In order to figure that out, everyone's got to multiply by the same value, in this case 5, in order to get it back to the original. If you want to try and go more complex, you can, but what I want it to be is when you're done, I want that result to be there. So let's take a look at this one and let's see how we can make this one a little bit more complex. All right, I'm going to pick my LCM in this case, I'm going to identify my LCM. I'm going to say that it's going to end up being 15 is what I want to end up multiplying by. And I'm going to say that if I do that, I'm just going to pretend, hey, I multiplied by 15 to get there. I'm going to say that it was a 3 that canceled out, right? Leaving me with 5 times 3. That's how I get my 15 there. All right, and I'm going to say in this case here it was a 5 that canceled out, giving me 3 times 5 is my 15. And in this case here it was a 15 that canceled out. So in order to get this, I'm going to have to go back to 1 over 3 minus x over 5 equals negative 7 over 15. And there's my more complex one. Now at this point, if you multiply by 15 across the board, you'd end up getting 5 minus 3x equals negative 7. So that's what we want you to do. Take one of these equations, make it more complex, and then give it to your partner for them to solve.